Students, welcome back. The purpose of this video is to explore scientific notation and arithmetic. So we learned a little bit about scientific notation in class. Remember that generally in scientific notation we want to keep one significant figure before the decimal and two significant figures after the decimal, and then you have your times 10 to the exponent. But sometimes we want to also do arithmetic with these numbers, and I'm going to show you how to do that here in this video. So let's begin with multiplication, and remember that when we multiply numbers that are in scientific notation, we simply add the exponents together after multiplying the antecedents. So for example, when we have 2.1 times 10 to the third times 3.45 times 10 to the fifth, we simply have 2.1 times 3.45, which is equal to 7.245. Now remember, we still want to keep proper sig figs here, and when we multiply numbers, we keep the lowest amount total, not just after the decimal, but all together. So in this case, we have we're allowed two significant figures total, so we have 7.2 times 10 to the 8th. And the way I got 8th is that I added the 3 and the 5 together. So let's do the same thing here with the second number. We have 1.0 times 1.0, and I know that I'm allowed three significant figures, so I can go ahead. I already know that I'm going to have 1.00 times 10 to the, and when I add 2 and negative 4 together, I get negative second. So my answer is 1.00 times 10 to the negative second. Now I hope you realize that multiplying these two numbers together, so multiplying 1.00 and 1.00 with different exponents is multiplying two completely different numbers. So 1.00 times 10 to the second is the same thing as 100, and 1.00 times 10 to the negative 4 is the same thing as 0.0001. So you're multiplying 100 by 0.0001, so you're essentially getting a much smaller number. Okay, let's move on. When we have division, we know that the rule is to subtract the exponents instead of multiply the exponents. So you do the operation like you normally would, and for this first one we have 9.00 divided by 3.0. So remember, my answer has to be in proper sig figs. I'm only allowed 2, so my answer is going to be 3.0 times 10 to the, now I need to subtract 2 minus negative 5. 2 minus a negative 5 is the same thing as saying 2 plus 5. So this is times 10 to the 7th. Let's look at another problem. Same thing here. So 4 divided by 2 is the same thing as 2.0 times 10 to the 8 minus 6 is just second. So that is your answer. Seems pretty easy to me. Should be pretty easy for you. Okay, addition and subtraction get a tad bit more confusing, but not really. So for example, what you really need to remember in addition and subtraction is A, of course, to keep proper sig figs, the lowest amounts after the decimal, lowest amount of sig figs after the decimal given in the problem. And also, make sure that your exponents, so what I want to do, okay, so your exponents, so this 10 to the 4th and 10 to the 4th are equal. And if they're not equal, you have to adjust them. So let me show you how that works. So here in this case, in the first problem, we see that our exponents are equal, so we can go ahead and simply just subtract the two numbers. So we have 2.97 minus 3.1, so I get a negative 0.13. So here, let me just write down negative 0.13 times 10 to the 4th. Now, this isn't really proper scientific notation because remember, you always want to try to keep at least one number before the decimal. What comes after the decimal depends on your problem. So here in this case, we're allowed only one significant figure after the decimal. So what I would do is I would just simply move this decimal over to the right one space. And what happens to my exponent when I do that? Well, when I move it to the right, I have to take the exponent down 1. So the 4 will become a 3. So my answer really should be negative 1.3 times 10 to the 3rd. That should be the correct answer. Okay, let's do the next one. We got 4.33, but here we have an issue. Now this 10 to the 1st is a big problem for us because we really want it to be 10 to the 2nd, or we want this 10 to the 2nd to be the same as 10 to the 1st. It doesn't really matter which one you manipulate. What you can do, let's just go ahead and make the second number, the 2.97, 10 to the second. So let me put that in a different color. So this actually should read 2.97, oops, I just wrote down the same exact thing. What it should read is minus 0.297 times 10 to the second, because remember, when you move the decimal over to the left, the exponent increases. And now I can very simply subtract these two numbers, 4.33 minus 0.297, and the answer that I get is 4.033. Remember, I'm only allowed two decimals based on this problem, so I get the answer of 4.03 times 10 to the second. Now you may be saying, whoa, Patel, if you take a look at the problem, negative 0.297 has three decimals, but remember, it's determined by the lowest amount of decimals in the significant in the number itself. So again, 4.33 has less after the decimal than the 0.297. So in any case, take a look at the original problem, not after you manipulate things, to get how many significant figures you need to have before or after the decimal. So addition works the same exact way. So what I want to do is I have exponents here that do not match, so I want to make them match. I'm going to just go ahead and make this 10 to the fifth a 10 to the third. So I'll put 0.0311 times 10 to the third, because I want to take it down two notches, plus this number. So then I get 0.0311 plus 8.111, and I get 8.14. Of course, think about sig figs again, and you actually should have let me just put it here, equals 8.14 times 10 to the, well, third. Okay, so I hope that made things a little bit easier for you. You can probably watch this video again if you need to, but that is arithmetic with significant figures. Oh, actually there's one more thing in class, and that is when you raise the number expressed in scientific notation to a power. So you carry out the operation, then you multiply by that power. So very simply, if you have something along the lines of 2.0 times 10 to the third, and you square that exponent, what you end up doing is you should square, sorry, I'm trying to find my laser. You should square this number, because that's what it tells you to do, and then multiply the exponents together. So 2.0 squared is just 4.0 times 10 to the, and then you again multiply the 3 and the 2, so you get 10 to the 6th. Okay, let me just give you another example for kicks. If you have 3.0 times 10 to the 7th, and you square that, again, you're going to go ahead and just square the 3.0, so you get 9.0 times 10 to the, and then multiply the 7 and the 2 together, so you get 14. Okay, that's that.